Hi guys, Mike from Model Railways Unlimited with a slightly different model rail video. This time I'm going to attempt to build from scratch a model railway DC controller. Now it is not pulse width modulated because I don't really believe that's best for our motors. Pulse width modulation does have a place, but for me it doesn't in my model railway anyway. So what I'm going for is a high performance closed loop controller, and this is the circuit diagram you see here. Closed loop means it includes the motor, a bit like feedback in its circuit, and has a little bit of a compensatory system within it. Therefore the motor speed is maintained. But this controller, I'm not sure quite how old it is, I found it in this old book, but it says that it produces really great control. So let's have a look at the components I'll be using to build it. So we have some Vero board, or breadboard as it's known, which is how I'll mount the components. We have our change direction switch. I have the main power transistor here, which seems to be a Darlington in one package. We have the signal transistors. Well, I only need one of these, but they come in packs of 4 or 5 as you see there, and these are used as a voltage comparator. It's this bit in the circuit. Diodes, well, I didn't need them this large or this powerful, but they'd be perfectly adequate. Big old heatsink to mount the power transistor on. There's our variable pot to control the speed, and a nice shiny metal knob to go on it. It doesn't look too much. Look. Welcome back. Here we go now then. What I like to do before I do any construction is plan out the circuit. So we have luckily a circuit diagram this time. So I will now place all the components that we're going to be using. So this is the main power transistor that's going to drive the trains for us. And within this one package are all these components, including the diode. So we'll place him there. This little transistor will be our comparator transistor, which you see here, which will drive the main transistor. Obviously we've got a toggle switch for direction control, which will be there. Now this diode is to protect the circuit. It doesn't need the massive diode that I've got there. One in 4001 would more than suffice, but I had those in stock, so there's no problem using it. Now the 10k resistor is there, and that will be there. So here's our variable pot, which is this one. So it's 22k, 22,000 ohms, and it sits between the plus and negative rail, and the middle output is tapped off and forms a voltage comparator. So that will go there. But with this one, it's also got a switch built in. I'm going to use that, I think, with an LED to say when your controller is away from the off position and you're beginning to put volts to the track. I think that would be a good idea, rather than having one that just shows that the power supply is live. So we need to add in this little LED, and so we need to adapt the circuit for that. The LED will be protected by a 1k ohm resistor. That'll be fine. It's a small LED. And the other part of the circuit is the rectifier. I found this WO2, which will actually sit here, and I'll have the output of the transformer, 16 volts AC onto that, and that will give us our 16 volts DC that we want. So I'll just adapt the circuit diagram to show the LED, and we'll come back and have a look at that. Right, so very roughly I've sketched in where the LED will go. I've shown a box round the variable pot and the switch because it's all part of the same thing, and I've shown the 1k resistor that protects the LED. So that then is our circuit, which we now need to build. Now my next step will be to plan it out on this Vero board, which is conductive strips which are insulated from each other. You can drill them out to isolate, so if you were to put a resistor through, you could drill it out and isolate it so that the resistor counts. So my next job is to plan that, bearing in mind that I want to mount this heatsink at one edge. Those pins on the end of that go through the board. to give it some stability, and that is for the chip. So that's what I've next got to think about, and that will be in part 2. Now just going in close, one of the things that we need to be ready with is the pinouts of the transistors. So you can see I've done myself a little diagram there of the transistor at that location, noting the connections. And then for the big one, same thing. See, I've got base, emitter, collector, and there's the pinouts for the TIP 147 as it should read. Apart from that, the circuit is relatively simple still.